Today, we'll illustrate a recommended orbital welding process for AL-6XN tubing. Welding practices for this alloy are similar to those used on other stainless steels, with one notable exception. That exception is the requirement for an additional alloy to be consumed in the weld. Before you begin, make sure the surfaces of your components are clean to remove any organic materials, moisture, and dirt. Use an isopropyl alcohol bath to clean these surfaces. If these contaminants are not removed, they can produce unwanted results, such as pits and unwanted colors. We first start with an alignment tool to help position the components for proper fit-up. There are many tools on the market to do this, and we have chosen a piece of stainless steel angle for this application. Placing the tube in the angle channel allows us to free our hands for other operations needed during the fitting process. Another option is to hold the components together using a specialized pair of clamps. This is especially useful when conducting field installations. The second step is the installation and alignment of the weld insert ring. This insert shape looks like a flat washer that is designed for thin wall tubing. The weld insert ring, also known as a consumable insert, is an integral part of the weld joint. It is required in the weld to maintain a corrosion resistance that is equal to the base metal after welding. Never use filler wire in place of weld rings for sanitary tubing due to the possibility of insufficient alloying in the weld root. There are several types and alloys of weld insert rings. The insert ring alloy must have a higher molybdenum content than the AL-6XN alloy to compensate for alloy dilution on cooling. We typically use alloy C22 as a weld insert material. Align the welding insert ring in the opposing component with the tube already placed in the stainless steel angle. These three components should be held together tightly, and there should not be any visible gaps between them. Before tacking the assembly, an argon purge gas should be applied to the ID. Adequate purge time should be given to prevent oxidation on the inside of the tubing. Tack all three components together. These skin tacks, as they're called, should be very light. Remember, it's important to not penetrate the tubing wall. Full penetration tacks require a high purity of purging gas and should be avoided. After tacking the components together, tack welds should be wire brushed to remove any surface color which indicates oxidation. The wire brush should be made from stainless steel to prevent surface contamination or iron deposits. It is crucial that this wire brush is only used on stainless steel. Place the tacked assembly in the orbital welding head. Align the weld joint so it's centered with the rotating tungsten. Once aligned, clamp on the end of the assembly and recheck the tungsten alignment. If necessary, make any required adjustments, then clamp the other side of the assembly as shown. Apply an argon shielding gas to the ID of the assembly. To do this, both ends of the tube should be plugged. The gas purging time will vary depending on the volume of atmosphere that needs to be evacuated. We typically allow enough gas flow time to exchange 4 times the original held volume. For high purity applications, there are other methods that can be used to ensure that the ID of the assembly has been properly purged. In some cases, you may want to monitor the escaping gas with an oxygen meter. You are now ready to start the welding process. Orbital welding program parameters will be very similar to those used on 316 stainless steel. In most cases, you will find that the heat input will need to be reduced just slightly compared to 316. After welding is completed, remove the assembly from the welding head. When visually inspecting the weld, the first thing you will see is a weld bead that does not look like a typical 316 weld. Be sure to make test welds before the project begins and share these with the customer. It is important for all parties to understand the differences in weld appearance with AL-6XN. Weld appearance can be somewhat misleading when visually compared to similar welds made in 316L stainless steel. A typical AL-6XN weld will have non-uniform freeze lines and slag islands in the weld bead. These slag islands are dull or blue-gray in color and adhere to the surface. The appearance of light and dark spots on both the inside and outside of the weld is common. Heat-affected zones can also have discoloration and are generally a little darker than conventional 316L stainless steel welds. If you have any questions about the welding or application of AL-6XN, please contact CSI at 1-800-654-5635 or 417-831-1411. or you can always reach us online at csidesigns.com. We have a knowledgeable staff ready to help you with your alloy needs.